We've already discussed independent events, where one event occurring does not affect the next one. But dependent events would be the opposite of that, where if one event happens, then that does change the probability that the next event happens. A lot of times you'll see the word problem using the phrase without replacement, which means you would not put the card back in the example with drawing cards from a deck that we did earlier. The formula is still the same. You do the probability of the first event times the probability of the second event. However, that probability of the second event will be different because the first event happened. So here's an example. We have a deck of cards. Remember, there's 52 cards in a deck. And we're going to draw one card without replacing it. And then we're going to draw a second card. And I want to know what's the probability that the first card will be a queen and the second card will be a jack. So there are 4 queens in a deck. So when I go to pull the first card, there's a 4 out of 52 chance that I'll get a queen. Once I've taken that queen out of the deck, there's only 51 cards left in the deck, 4 of which are jacks. So the chance of getting a jack on the second draw after I've already taken one card out is 4 out of 51. When I multiply and simplify this, I get 4 out of 663. Now these next 2 problems are going to look familiar to you because they're the same 2 that we did in the last video on independent events. Finding the probability of drawing a king and then a king, and the probability of not drawing a queen and then drawing a 7. What makes this time different from the previous time is that in the last video I mentioned that you were going to put the first card back in between draws. This time you're not going to put the card back. So the probability of drawing a king for the first card is still 4 out of 52. But once you've taken that king out of the deck, now there's only 3 kings left out of 51 cards total. When you multiply and simplify this, you get 1 out of 221. The probability of not drawing a queen and then drawing a 7, this is a little bit more complicated. So the probability of not drawing a queen, if you remember from last time, was that there are 52 cards in the deck total, 4 of which are queens. So if you do 52 minus 4, there's 48 left over that are not queens. And the thing is that I don't know whether that first card that I drew out, I want it to not be a queen, but I don't know whether or not it was a 7. So it could not be a queen and be a lot of things, but maybe it's a 7, maybe it's not. So I actually have to do 2 cases here. I have to do one case where maybe the card that I pick out that's not a queen, maybe it is a 7, or maybe it's not. So let's say that it is a 7. If it is a 7, and then I go to draw the second card and I want to know whether or not that one's a 7, there's only 51 cards left, and because I drew out a 7 for the first one, there's only 3 7s left. However, if when I pulled that original card out that was not a queen, if it was not a 7, there are still 51 cards left in the deck, but there are 4 7s left in the deck. So when I multiply and simplify here, I get 12 out of 221. Or if it was not a 7 that I picked out on that first card, I get 16 out of 221. Or means add. If you have 2 different possible outcomes like this, we're going to add them. So then my final answer is that there'd be 28 ways out of 221 outcomes where the first card I could draw would not be a queen and the second one would be a 7.